All right, let's dive into a pretty radical idea from Louis Liebenberg's work. The whole concept is that the real origins of science, yeah, science, can be found in the ancient art of tracking. We're pulling this from the chapter on scientific and cultural links, and we're going to zero in on the subchapter all about the scientific method.
So what on earth could a Kalahari hunter, following the trail of an antelope, possibly have in common with a physicist in a lab coat studying subatomic particles? Seems like a stretch, right? Well, as we're about to see, the answer is everything. It's the very foundation of how we think scientifically.
And here it is, the core thesis from the source material. The argument is that this sophisticated, creative, and critical way of thinking that we associate with science, it isn't some recent invention. Nope, it's actually an ancient survival skill, something we honed over thousands and thousands of years simply because we had to find food.
Okay, so to see how this actually works, let's jump into our first heading under the scientific method, critical discussion. This is all about rational debate, and just like the title says, it often happened right there, arguing over tracks in the sand.
The source defines this as the absolute heart of scientific progress. It's not about just listening to the person with the most authority. It's about everyone challenging ideas based on the evidence to get to the best possible explanation. I mean, that's the bedrock of modern peer review. And as we'll see, it was also the bedrock of a successful hunt.
The source gives us this brilliant real-life story that just nails this point. You've got two trackers from the Exo people, Kayete and Nyamkabe, and they're staring at the exact same tracks, but they see different stories. Kayete is the more dominant guy, and he convinces the group his interpretation is the right one. But Nyamkabe, he's quieter but more imaginative, and he has a totally different theory. And guess what? He initially loses the argument, but in the end, he's proven to be right. The crucial lesson here is that the truth was found by testing ideas, not by just bowing to the loudest voice in the room.
This brings us perfectly to our next heading, conjecture and refutation. Because beyond just debating the evidence you have, science needs a creative spark. It's that ability to make a bold guess, a hypothesis, and then be absolutely ruthless in testing it.
Okay, I know, hypothetico-deductive reasoning is a mouthful, but the concept itself is just beautiful. It's basically a formal way of saying you have this dialogue going on in your head, a back and forth between your imagination and your critical mind. You make a creative leap, and then you use cold, hard logic to see if that idea actually holds up in the real world. That right there is the engine of discovery.
And here is a perfect example. The trackers observe something weird. A gems buck is running from hunting dogs, but it should be turning to fight them. That's a puzzle, an anomaly. So the tracker makes a creative leap, a hypothesis. Maybe the gems buck thinks it's being chased by lions because it smelled their fresh scent nearby. So what do? They go check. And boom, they find fresh lion tracks confirming the hypothesis. A totally new piece of knowledge about animal behavior was just discovered, not by just watching, but by explaining.
This slide just draws a stunningly direct line between the two worlds. The tracker looks at visible marks in the sand and explains them with an invisible story about what the animal was doing and thinking. The physicist looks at visible trails in a particle detector and explains them with an invisible theory about particles and forces. It's the exact same pattern of thinking.
So that leads to a pretty big question. Where do these creative hypotheses even come from? Well, our third heading, anthropomorphic models, gets right into the power of imagination. For trackers, the key is to basically get inside the animal's head.
Now, we're often taught that anthropomorphism, giving human qualities to animals, is totally unscientific. But here, it gets reframed as a seriously powerful modeling tool. It's not about actually believing an antelope feels sad. It's about using your own experience as a human to build a predictive model of that animal's behavior. It's a creative, scientific shortcut that's based on the simple question, what would I do if I were that animal?
So this slide just breaks that whole process down. It all starts with observing the hard evidence. Then you ask that key empathetic question, what would I do here? From that, you create a mental model of what the animal is likely thinking and feeling. And then the final, most crucial step, you use that model to predict where it's going to go next. And this insight from Liebenberg, wow, it just gets right to the heart of it. It's such a deep form of mental modeling that it becomes this intense empathetic experience. To really truly predict the animal's next move, the tracker has to, in a way, become the animal in his own mind. And that brings us to our final heading for this subchapter, intuitive problem solving. So, what happens when the data is messy, when the trail goes cold, when the information is incomplete? Well, that's where intuition becomes a critical scientific tool. Again, intuition isn't being presented here as some kind of magic or psychic power. It's defined as a cognitive tool, a way of reaching a conclusion when the evidence is weak or confusing. It's the mind's incredible ability to see a pattern in a storm of noisy data, drawing on a lifetime of subconsciously processed experience.
And you can immediately see how vital this would be, right? How old is this track? I mean, there are a million variables. The sun, the wind, the humidity, the type of soil. There's no simple formula. An expert tracker intuits the age. They can look at a smudge in the sand that means nothing to you or me and intuitively reconstruct the full print. They can even get a feeling that an animal is close by based on 1,000 tiny signs they aren't even consciously processing. So let's bring these 4 ideas together. We've seen how trackers use critical discussion, how they make bold guesses and test them, how they build mental models, and how they use intuition. What does all of this tell us about the origin of science itself?
This is the really profound conclusion. The ability to do science isn't some fancy cultural development from the last few centuries. It's a fundamental part of the human mind. It's an intellectual toolkit that evolved because it gave our ancestors a huge survival advantage. The first scientist wasn't in a lab coat. They were on the hunt. This final comparison just makes the whole argument crystal clear. The tracker's critical discussion out in the field, that's the direct ancestor of scientific peer review. Their process of conjecture and refutation, that's the very essence of experimentation. Their anthropomorphic modeling is a kind of theoretical modeling, and those intuitive leaps are the sparks that lead to major conceptual breakthroughs. It's the same mind using the same tools, just in a very different context. And so we end on this thought. If the ability to think scientifically is this deeply wired into our evolutionary history, if it's a fundamental part of being human, what does that imply about our own potential? It kind of suggests that the ability to observe, to guess, to test, and to understand, well, that isn't just for a select few geniuses. It's our shared inheritance.